Welcome back, everyone. In this video, I'm going to walk you through some problems involving electronegativity and determining bond polarity. In this first question, you're asked to determine in which compound does chlorine carry the largest partial negative charge. And then you're given four choices. The way that you would be asked to evaluate this is different from what I'm going to show you, but it's going to raise an important dilemma. So let me show you one way you could do this, assuming that you had the actual values. We need to determine which one has the largest difference in electronegativity, or the largest delta chi. And so if we look up the values for the electronegativities, we can see that the chlorine-fluorine would have a difference in 0.82. Chlorine-chlorine is neutral, or rather has no difference in electronegativity. Chlorine-bromine has a difference of 0.2, and chlorine-iodine has a difference of 0.5. This would mean then that the largest partial negative charge on the chlorine is going to be the one where the chlorine is more electronegative than the other element that it is bound to. So while this is the largest difference in electronegativity, chlorine has a partial positive charge. And so we can eliminate that because it has a positive charge, this because it has no charge. And then comparing these two, we see that chlorine is a negative on both cases, but it is more negative in the case of the iodine with the chlorine. And that's because there's a larger overall difference. Now, without looking up the values, how could you solve this? Well, by remembering the trend in electronegativity difference, or in electronegativities on the periodic table. In the periodic table, electronegativity increases to the right and up, which means then that, and it's also important to note that the noble gases have no electronegativity. They don't want electrons. So the most electronegative element is fluorine. Let's put that down here. We have fluorine. Chlorine is underneath it on the periodic table, and then bromine, and then iodine. And so you would need to be able to compare them, knowing that in terms of increasing electronegativity, iodine is least, bromine is next, chlorine is next, and then fluorine is next. And the larger the difference, the distance on the periodic table, the larger the difference in electronegativity. So while you would not need the actual values, you could have solved this by knowing that the fluorine is more electronegative, so it has to have the negative charge. And then iodine to chlorine is a larger difference than iodine to bromine. In this next question, we want you to rank the following bonds in order of increasing charge separation, or in other words, bond polarity. And you're given the four bonds. So again, I would recommend in this case you pause the video and try and solve this on your own. Welcome back. So, did you take a look at the periodic table? Hopefully so. So, fluorine is located here. Potassium is located approximately here. Carbon is here. And oxygen is in between. So, we know that electronegativity increases up and to the right, which means if we were to rank them in terms of electronegativity, potassium is lower than carbon, which is lower than oxygen, which is lower than fluorine. Now, we're looking though for the largest increasing charge separation. Any element bound to itself is nonpolar. And since there's the largest difference in electronegativity between potassium and fluorine, this is going to have the most separation. And then the other two elements are in between. Now, how do we evaluate them? Well, one way to think of it is if we were to arbitrarily give ourselves some values. Now, I don't remember them, But let's just say that fluorine, it's the most electronegative. It has a value of 10. Oxygen is in between carbon and fluorine, so let's give it an 8, and let's give this a 6. So what's the difference in electronegativity? In this case, we're calculating it to be somewhere around 4. In this case, we're calculating it to be somewhere around 2. Now, those values are absolutely not true. They're not the true values, but it helps us to break this problem down. And what we can see then is that fluorine-fluorine bond is the least polar, potassium-fluorine is the most, and then carbon-fluorine is second most, carbon-oxygen is second least. So putting those in ranked order, we can eliminate those two very easily. We know potassium fluorine is the highest, so it's between A, B, and C. CO is second, and so the answer is C. That's it for this video. Thanks for watching. If you have questions, ask on Piazza in office hours or in recitation. Have a good day.